In a remarkable scientific breakthrough, Chinese researchers have stumbled upon a rare mineral that might be the game changer the electric vehicle industry has been waiting for. With the fortuitous discovery of a mineral known as Niobobaotite, China's lead in the EV race could be poised for further expansion. Niobobaotite is an extraordinary concoction of niobium, barium, titanium, iron, and chloride, as reported by Life Science. This newfound treasure trove of minerals has the potential to revolutionize the EV industry and solidify China's position as a powerhouse in the green energy transition. But why is Niobobaotite such a gem for China? And how will this discovery affect the EV industry as a whole? Niobium is a rare earth metal and one of the most coveted elements, which plays a pivotal role in driving technological progress. Its applications extend across various fields, from making batteries, superconductors, and cutting-edge military aircraft to space-bound rockets and various scientific equipment, where its exceptional superconductive properties are indispensable. Niobium also acts as a potent enhancer of steel, making it simultaneously lighter and stronger. In fact, a mere 1% infusion of niobium can yield substantial improvements. The driving force behind the remarkable performance of battery streak lies in niobium, the 41st element on the periodic table. Niobium possesses a unique characteristic. When it interacts with oxygen, it forms a porous crystalline structure known as niobium oxide, or niobia. It's the structure's impressive surface area that makes niobium a game changer in battery design. In a conventional battery, the journey of positively charged lithium ions begins at the lithium metal cathode and ends at the negatively charged anode. The anode, usually composed of graphite, features a crystalline carbon structure that captures and detains these ions through a process known as intercalation. While this method functions adequately, it comes with its share of challenges. For instance, it necessitates that the lithium ions penetrate deep into the graphite lattice and undergo a chemical phase transition, which generates heat. Problems can arise if the metal ions fail to penetrate deeply into the carbon matrix, causing them to cluster and form a troublesome metal coating, a predicament known as lithium plating. This issue looms large for both current and future battery technology. However, with niobium, the problem is neutralized. Substituting graphite with niobium in the anode proves to be a remarkable solution, effectively addressing both challenges. Thanks to the expanded surface area of niobium oxide molecules, lithium ions no longer require deep penetration into the crystal lattice or undergo phase transitions to stay in place. Instead, they comfortably rest on the surface of the niobium structure, making it a smooth and efficient process of attachment and detachment. The origin of this groundbreaking battery design can be traced back to the halls of UCLA, where a team of researchers led by individuals like Bruce Dunn and Sarah Tolbert first conceived the idea. This kickstarted the journey, and 5 years later, the company is poised to make its mark on the market. This is why the discovery of Niobobaotite represents a true windfall for China. Currently, China relies heavily on imports to satisfy its niobium demands, with a staggering 95% of its supply sourced from foreign shores. Brazil, the world's foremost niobium provider, followed by Canada, has long held a strong grip on the niobium market. Notably, the Brazilian niobium mining company CBMM has invested a substantial $5 million in Battery Streak and serves as the exclusive niobium supplier for their innovative batteries. Additional financial support is poured in from a National Science Foundation grant and a pre-seed round courtesy of Act One Ventures, bringing the total investment to $6.5 million. However, this newfound resource has the potential to significantly tip the balance in China's favor. Acknowledging the significance of this revelation, the International Mineralogical Association Classification Committee has given its official seal of approval to the Niobobaotite ore, labeling it as IMA 2022-127A. This endorsement not only underscores the remarkable value of the discovery, but also hints at its potentially transformative impact on the mining and minerals industry. The reverberations of this groundbreaking discovery extend far and wide, with profound implications for the Chinese economy. The newfound local source of niobium has the power to reduce China's reliance on imports, injecting a healthy dose of vitality into the domestic economic landscape. But it doesn't stop there. This discovery could serve as a catalyst, propelling advancements in high-tech sectors and igniting China's technological evolution. The emergence of Niobobaotite ushers in a new chapter in the realm of science and technology. Niobium, renowned for its superconducting capabilities, particularly at low temperatures, plays a pivotal role in various critical battery applications. Its superconductive prowess also plays an irreplaceable role in producing cutting-edge EV technologies. The potential is enormous. Depending on the volume and quality of this newfound niobium resource, China could become self-sufficient in this critical material. This newfound autonomy not only strengthens China's position in the global rare earth metals market, but also bolsters its self-reliance in key industries. It's a transformation that could redefine China's strategic standing on the world stage. Timing is everything, and in today's world, the clock couldn't be ticking any better for China. The global thirst for niobium is on the brink of an unprecedented surge, making this discovery a strategic game-changer. What lies on the horizon are tantalizing prospects in the form of niobium lithium and niobium graphene batteries, offering promises of reduced fire risks, lightning-fast charging speeds, and a lifespan that far outshines their lithium-ion counterparts. With these cutting-edge batteries gaining momentum and development, the demand for niobium is primed to shoot through the roof. Just a few years ago, cars were typically charged at speeds of 50 to 100 kilowatts. Today, charging at 150 kilowatts has become the new norm, pushing the momentum toward electric vehicle adoption. The exciting part is that there's plenty of possibilities when it comes to niobium-infused anode materials making a commercial impact. Battery companies are buzzing with enthusiasm, and innovation is rife. A short distance away from Cambridge, Niobolt is a key player working on fast-charging technology using niobium. In collaboration with two partners, Toshiba has also embarked on developing lithium-ion batteries that employ niobium titanium oxide as the anode material. Meanwhile, companies in China and the United States are zeroing in on niobium's potential. Eshion Technologies, for example, envisions the application of their niobium-based anode materials in various contexts. While there may be a better fit for passenger electric vehicles, the company sees potential in delivery vans, buses, trains, and even mining vehicles. Fast-charging batteries are needed, particularly for larger vehicles like buses. The idea of having buses idly sitting around for 6 hours each day doesn't align with efficiency. Instead, the goal is to make the most of them. By enhancing charging speeds for buses and other sizable vehicles, there's a possibility to use smaller, swiftly rechargeable batteries at the end of a bus route. This approach offers potential cost savings and reduces the overall weight of the vehicle. However, this shift may require a re-evaluation of infrastructure, potentially necessitating more charging stations than when buses are charged overnight at central depots. The ideal solution lies in striking a balance between the advantages and disadvantages of this approach. The downsizing of battery size has a ripple effect, reducing the demand for battery materials and subsequently curbing the environmental impact of production. In essence, the advent of fast-charging technology brings forth a plethora of benefits. It's a development that promises to become a defining selling point for certain segments, ushering in a brighter and more sustainable future. The discovery of Niobobaotite in China significantly impacts the EV industry. However, it also has geopolitical implications. China is already a dominant force in the EV industry, with a robust manufacturing sector and a growing market for electric vehicles. The newfound resource of niobium could further strengthen China's position as a global leader in this field. This development may raise concerns in other parts of the world, especially among countries with ambitions to become key players in the EV industry. The availability of Niobobaotite and the subsequent production of niobium-enhanced batteries could give China a competitive edge. The global EV industry's dependence on China for critical resources could also raise concerns among other nations and regions aiming to establish their presence in the sector. The supply chain vulnerabilities have been highlighted in recent years, especially as China dominates the production of essential battery materials like lithium, cobalt, and nickel. The addition of niobium to this list further solidifies China's pivotal role in the global EV supply chain. This growing dependence on China carries significant geopolitical risks. Countries or regions that do not have access to these resources may find themselves at a disadvantage, subject to the fluctuations and control exerted by the dominant producer. The competitive edge now gained by China can also amplify the economic and technological competition in the EV sector. This competition may drive other nations to accelerate their research and development efforts, creating a beneficial spillover effect for the global EV industry as a whole. Governments, private enterprises, and international collaborations will play crucial roles in fostering innovation, enabling more nations to compete effectively and contribute to the advancement of sustainable transportation technologies. Cooperation and diversification will be required as the world seeks to transition towards clean and sustainable transportation. Responsible resource management, ethical production, and global collaboration can help ensure that China's newfound resource doesn't become a geopolitical flashpoint, but rather a catalyst for global sustainability. But what do you think will happen? Will China rush to assert dominance in the sector, or will this new resource benefit the EV industry as a whole? Share your thoughts in the comments below. That's all from this video. See you in the next one.